Good morning, everyone. Today we will discuss the strings, the basic terminology applicable to strings. How do you store and retrieve the strings? Already we discussed when we discussed on single dimensional and multi-dimensional matrix. But strings are nothing but a single dimensional array ending with a slash 0 that we will discuss for the day. And the different operations that you are going to perform on strings. And one important aspect of strings is the pattern matching algorithm applicable in wide areas. Particularly we will discuss the KMP algorithm, where you are going to find out the presence of a substring in a main string. So that we will discuss for the day. In the previous session we discussed about the applications of array to polynomials, like if you have a polynomial like x square minus 4x plus 7, and if you have how do you represent this particular polynomial into an array, what is the degree of the polynomial, and the different operations like addition, subtraction, multiplication, as division is not allowed. We discussed elaborately the addition, which will be similar to subtraction. So also we discussed in brief about the ADT, which specifies how a polynomial is going to be represented, and the different operations like 0, make the polynomial as 0, or find out if it is a 0, and find out if you have been given the term, find out the coefficient and find out the degree of the polynomial, and attaching, etc., of which the significant function is the attach function. We discussed like that the polynomial. Also we discussed a simple C program where we considered a single dimensional array where the two polynomials, polynomial A and polynomial B, are going to be represented into a single dimensional array. So here in this instance, the polynomial A is going to start at this position, 0th index, and it is going to end at the very first position. Polynomial B is going to start at second position and it is going to end at 5th position. And we can similarly, if you are going to apply this one to addition of polynomial, how do we add the polynomials and what are the three different cases that we are going to come across? These things were illustrated along with the algorithm, a simple program with a live execution. Also we discussed in previous session the sparse matrix, where number of zero entities will be more when compared to non-zero entities. So where instead of killing the memory by storing zero elements, so we transformed into a triplets, a series of triplets where each triplet will be indicating the row index, column index of a non-zero element. Consider the 28. So for the 28 is going to be stored in the original sparse matrix as at the 5th row, second column as 28. So when the number of non-zero elements are very less when compared to zero elements, we will reduce. Here the dimension is only 6 cross 6, where only non-zero elements has only 8. So here not much non-zero elements, but if you have 100 cross 100 matrix where you have only 28, then obviously you are going to kill the memory unnecessarily storing the zero values. So to avoid that one, we use such kind of representation. Also we discussed about how do you use the sparse matrix using the triplets, and what are the functions that you are going to apply for the sparse matrix as create, transpose. Transposition will create a problem because we assume in the sparse matrix representation as the rows and columns must be there in ascending order, in the sense like all the rows in the first column of these triplets are going to be in the ascending order. Obviously they will be in ascending order, but in each row, consider the row 0 where the columns are going to be sorted in ascending order. So this is the basic need of this sparse matrix. So when you transpose, when you apply the operation of transpose on a sparse matrix triplet representation, then it might go wrong, because say when here in the first A of 1, because it is a diagonal element, so obviously there is no confusion as to store where it needs to be stored. But when you consider 0 3, when it transposed means the rows will be transformed into columns and columns will be transformed into rows, but that cannot simply happen when you are going to use the triplet representation. So this 0 3 will become as 3 0. So then in that case, where do I store? Because the rows and columns must be in order. So the 3 0 22 within the transposed matrix, where should I store? So that becomes a major hurdle when you are going to transpose. That we try to explain with the kind of representation like this, where you use this representation. So how many number of times each element is going to be appearing and where it is going to start. So using this understanding, we represented this. So the basic understanding of this one is, so 2 plus 1 is 3, 1 plus 3 is 4, 2 plus 4 is 6, 2 plus 6 is 8, 0 plus 8 is 8, etc. So using this representation, so here the number of times 0 is happening in this second column is 2 and its starting position is 1. So that's how you are going to indicate. So likewise, the same explanation applies to all the different elements here. So using that understanding, we try to transpose this triplet representation of this sparse matrix into a transposed one. So where all the rows and in each row the columns are going to be sorted. So the last column in this one is the steps how this sparse matrix is going to be transposed. The first step is 0, because we understand in the triplet representation of a sparse matrix that the first row will consist of a number of original sparse matrix rows, number of original sparse matrix columns, number of non-zero elements. So this is going to be as it is, and because this is the diagonal element, we start with it directly. This is the first step, and the second step is because it is 0 3 when transposed, it becomes 3 0. It becomes 3 0. Then this is the second step, and this is the third step, fourth step, fifth step, etc. So we discussed along with a program illustration along with this algorithm. How do you do that? This was explained in the previous class. So for the day we will discuss the strings. That was the glimpse of what we discussed in the previous class, and for the day we will discuss in what are the different what is the core difference between a character and a string in C language or in any other particular language. Particularly we discuss here with respect to C language. So strings are nothing but one-dimensional arrays of characters terminated by a /0. /0 is not two different characters but it is a null character. We treat it as, we treat /0 as a single character and it is being named as a null character. So by default the C compiler and C++ compilers attach /0 if it is a string. So a character like S, when enclosed within single quote, it becomes a character, but when enclosed within double quotes, it becomes a string, because when enclosed in a double quotes, by default it is going to attach /0 at the end, but might be the length of the string here, it will be only 1. /0 will not be considered for length. So the different languages specify the different functions. Most of these common functionalities in specific to C language are the string copy, which copies string S2 to S1. So what does that do is, here this S2 is going to be copied into the S1. All the characters of S2 is going to be copied into the S1. All the characters of S2 are going to be concatenated with S1 when you use strcat, and str length is find out the how many number of letters are available or how many characters are available within this S1. What is this strcmp is? So there will be three different values that it is going to return back. It will compare individual characters of S1 with S2. If all the characters are equivalent to or equal to the characters of S2, then it will return 0. Otherwise, if the string length of S1 is less than S2, then in that case it will return what you call a negative value. If the string length of S1 is greater than S2, then it will return a positive value. So 3 values are going to be returned. When S1 respective characters of S1 are equal to respective characters of S2, then it will return 0. Otherwise, if the string length of S1 is less than S2, then in that case it will return a negative value, and also at the same time if the string length of S1 is greater than S2, then it will return a positive value. So you need to be careful while programming, because most of the functions will return true if they are successful. If it is unsuccessful, then it will return false. But this is one of the peculiar function which will return the 3 values, 0 and non-zero characters. But you need to be careful while using this particular function. So strchr, you are going to find out the presence of ch in S1, and str is find out the presence of the substring S2 in S1. So these are the few functions which will be generally used in different languages, not limited to these half a dozen functions, but there are plenty of functions that are available. Meanwhile, we will discuss depending on the different needs. So followed by we discuss the string pattern matching algorithm. What do you mean by pattern matching algorithm is, you need to find out in a large text the presence of the pattern. I will be giving a pattern where you have a large text within which you are supposed to find out where its presence, in which locations its presence, and find out if it is present more than one time, in which and all location it is going to be present. So that is what the understanding of string pattern matching algorithm is. So you are going to match a pattern within the original string using different techniques. Most common technique is the brute force. So the brute force is going to be the most common, but it gives the least performance. Maybe in this case it is going to give the least performance with respect to space and time complexity. So what this algorithm is going to do is, until entire pattern is found, or until you are going to reach the end of the text, you evaluate this if else statement. In this if else statement, what you do is, you are going to match the individual text letter to the pattern letter. If you are able to match it, then move on to the next letter of the text and match it, next letter of the text and match it, until all the letters in the pattern are going to be matched. At any case or at any instance of time, if it is not matching, then move the pattern down text by one letter and start again afresh, matching from the first letter of the pattern with the text letter. So this is brute force technique, which gives the least complexity with respect to time and space. So here when we consider the example, so ATC is going to be ATA is the substring which we are going to match with the respective positions. So here ATA is going to be matched with AGT, then with GTT, then with TTA, then with TAC, then with ACC, then with CCA, then with CAA, then with AAT, then with ATA, but it is found. ATA, all the respective characters are going to be found. So then you start, you say that you conclude that at the set position it is found. But this is not the only one example. So in the earlier example, we found that the substring's presence at the very last. But if it is in between, we say that the string is found at the position 3. So if the index is going to be starting with a 0, if the index is going to be starting at 1, then we say that the substring is found at the position of 4. But this is not the only one example where we have only one occurrence. There are some other instances where we may have multiple occurrences of the pattern within the given text. Say APAA is the pattern which we are finding out in this text. Its presence is there in two instances, one at the 4th position and the other at the 10th position. So if we have to report at the both position, maybe brute force technique is going to find out the first presence of the original pattern within the given string. But if in any instance we need to find out multiple occurrences also, then those algorithms are going to be different. So we discuss how we do this. Before that, we discuss the applications of string pattern, because there are immense number of applications. Every day you and me will be using this pattern matching algorithms. Say in scientific fields, the DNA sequence, which will be quite a very long sequence of letters, which you need to map with a small 4-letter to 8-letter alphabets, where you are going to find out this 4-letter to 8-letter alphabet within the given long sequence of DNA. Or in all the word processing or web searching or in the desktop search, etc., we will be using pattern recognition algorithms. Also in matching of string bytes containing graphical data or the machine code, and every time we either in DOS or Unix, when you are going to find out the either if you want to find out the presence of a file or a directory within the file structure, will be using this string pattern matching algorithms. It has got immense applications. So just to discuss one small program which uses the brute force technique. So here we consider the main function where we get the original text, where we get through the getS function the pattern or the substring which needs to be found out in string A. So here in this case, A is the original text which will be passing it to the match function, and B is the substring which will be passing it to the match function. So if it is returning a negative value, then so if the position not equal to negative value -1, then it indicates that we found the substring or the pattern is found. In otherwise it is not going to be found. So how the function will be working is the match function. So the match function will accept the text and as well as the pattern. We declare a few local variables which will be holding the length of the text, length of the pattern, and intermediate variables C, D, E, position, etc. So length of the original text, length of the pattern. If the length of the pattern is greater than length of the text, that means that it cannot be found out. It cannot happen at all. So we will be returning a negative value. Otherwise, we use the two loops embedded one inside the other. So here the outer loop will be. So what we do, what is the condition is C must be less than or equal to text length minus pattern length. Why this? Because we should not exceed the text length while comparison of the respective characters of the text with the pattern length. So that is why we place this particular condition. So within the outer loop, we initialize the respective positions to our pointers to the E and C. The E and C are the pointers respectively to the text and as well as the patterns. So here inner for loop will take care of the pattern. It's going to take care of the patterns. So whenever if you find that the letter in the pattern is going to match with the letter in the text, we increment the index of text. Otherwise, if it is not matching, if it is in any case if it is not matching, then we break it from the inner loop, not from the outer loop. So we break it and we match the next test. So at the end of the execution of the two for loops, if we see that if D is going to be equal to pattern length, then we indicate that it is going to be returning the substring or the pattern has been found. Otherwise, we return an -1 indicating that the substring or the pattern is not found within the original string. So this is the C program which is based on the brute force technique. But this will be in need of, because you have a two inner for loops. So definitely if the text length is M and pattern length is N, then definitely the complexity of this one will be big O of, say if you consider M and if you consider pattern length as N, then you will the complexity of this algorithm will be a big O of M cross N, which is quite high when compared to the other algorithms of the type string pattern. So we will discuss why it is bad. So here if you consider a string of say some length, arbitrary length, and the pattern is going to be there only at the last position, the pattern is going to be 4 zeros followed by 1. So every time in this when you use the brute force technique, all the 4 individual characters are going to be matched only when you match the last character. the fifth character, you find that it's not possible, and you conclude that the substring is not matching. So you like that, if you compare the 12 times, only in the 13th time you find that the substring is matched. But even though you found out at the 13th time, unnecessarily you matched the character 60 number of times, the 60 number of comparisons were made. Maybe you might avoid some of the comparisons. So the basic intent of the next part of the explanation or the further algorithms like Boyers-Moore algorithm or KMP algorithm, or how to reduce these many number of comparisons. So if we can reduce the number of comparisons, then we might decrease the complexity that this function is going to take. So if we use this simple technique, say if I need to find out if I need to find out SENTE in this string, as this is a simple sentence, SENTE needs to be found out. So when I match this, in the very first instance itself, I find that S is not matching with the very first letter. So I will move on to the next letter like that. If S is matching, I will match the second letter. If I am not able to match with the second letter, then I will move on to the next letter, etc. So this will drastically reduce the number of comparisons. Even though it is going to be found out like this, we are not matching. The moment we find that at the very first position or the second position, if we find that the characters are not matching, we skip the rest of the comparisons. Thereby we reduce the number of comparisons as compared to this case. So there are plenty number of algorithms. We discuss the KMP algorithm. So this algorithm was conceived in 1974 by Donald Kunth and Pratt, and independently by Morris. So that is why in combination this algorithm is popularly known as the KMP algorithm. The KMP algorithm. So how the string pattern matching algorithm is going to basically work is based on these steps. So here we need to retain information from previous or prior attempts. There need to be some way to understand that some part of the string is already matched. So we need to skip those comparisons. By that we can avoid some number of comparisons. By that we reduce the time complexity. So compute in advance how far to jump in P. So here P is the pattern and T is the text. In this case we always refer, again I will repeat, P is the pattern which we are trying to find out its presence in text. So compute in advance how far to jump in P when a match fails. So here suppose the match is going to fail at the jth position of pattern. So at the jth position of, when you are going to compare the respective letters of the pattern with the original text, so at the jth position you are not able to match, or the respective characters are not matching, then in that case we need to memorize this particular fact. So how do we do that? Based on that you have the different algorithms. So we concentrate on the KMP algorithm. So here the rest of the explanation goes like this. So here in this algorithm, J is the position or the position in the text, and pattern J is the position in text, in the sense like if P of J means J number of characters have been already matched that were present in both P and as well as in text. So I is the position in the text in this case. So I is the position in the text. When you say I plus 1, so the I plus 1th text is going to be equal. Now at some instance, say if I plus 1 is going to be failing, then, but we know that already the T of I plus 1 is already equal to P of 1. Then shall I compare P of 1 with P of 0? So if it is in that case, if it is equal, if so increment by 1. No need to look at the text at all. So I will directly do it. What if P1 is equal to 0, P2 is equal to P1? So what should I do? Then increment J by 2. So in that way we record our we retain the previous attempts. We are not simply killing the time by doing the repeated comparisons. So what basically this understanding of this one is, say if you are going to compare, consider this example. So here in this case, A, B, C, A, B, C, A, B, D, E, F is the original string. We are trying to find out A, B, C, A, B, D is a pattern which we are going to find out in the original text. So if it is that case, we find out that by comparing A with A, B with B, C with C, A with A, all the respective characters are matching until when you compare C with D. Only at the last position you fail. So if it was the brute force, then I need to move by one position and start again. But in this case, when you consider this algorithm, so what we do is, in this case, before we explain the further part, you need to understand what is the prefix and what is the suffix. So when you consider this particular string A, B, C, A, B, or you consider S, T, R, N, G, S, within the string, S is a S is a prefix, ST is a prefix, STR is a prefix, etc. Or what do you mean by suffix is, this S is a suffix, GS is a suffix, NGS is a suffix, INGS is a suffix. So likewise, you define prefix and suffix, but the understanding of this algorithm lies in what part of prefix is matching with what part of suffix. So here in this case, when you consider this string, AB is prefix when you consider only A, B, C, A, B. So AB is a prefix, and as well as when you exclude this D, AB is a prefix, and as well as AB is also going to be a suffix. So AB prefix, AB suffix. So likewise, you are going to record, or you are going to retain the information about what is the common prefix and suffix at any said position. So we matched C and D. We need not again start with the position of B here. I will understand that already few of the characters were matched when I failed to compare C with D, and which were different. So I need not compare again with B, but I will start with this position AB, because just prior to C, AB, which happens to be the prefix and as well as the suffix, so this which is going to be in common, so I will skip these comparisons. So when I skip, so obviously I will be reducing the time complexity, I will increase my efficiency of my program. So that is how this algorithm is going to be working. I am going to find out which is going to be the common prefix and suffix that are available at any said position of the pattern. So to understand that one, the KMP algorithm is going to be defined with two procedures. One is KMP procedure, KMP pre-processing algorithm, and the other one is KMP algorithm, where you are trying to match it. So before concluding with KMP algorithm, we discuss first how the KMP pre-processing is going to be doing. We are going to be defining a table of size M. What this size M is? M is the size of the pattern. So the pattern of the size of the pattern will be M. So obviously here with this understanding, like LPS will be of the size what do you call M. So here what you do is, initially the first element LPS is going to be a single dimensional array. So LPS of 0 is 0. So LPS of 0 is 0. So I equal to 1, j equal to 0. So I until I crosses the M value, in the sense like all the characters of the pattern have been matched. Until that time you do this particular aspect. You are going to compare the ith position letter in P and jth position letter in the pattern itself. You are manipulating only the P and storing it into the LPS table. So here what you do is P of j you compared, you are trying to compare here p of j with p of I. If it is equal, then you store the j plus 1 value into the LPS of I and increment both I and j. If it is not that case, if they are not equal, then find out if j is greater than 0, in the sense like few of the characters were already mapped. In that case, you use the previous value of LPS of j minus 1. So we were currently at LPS of j, but we will take the j minus 1th position because we already calculated LPS of j minus 1. So we try to use that previously calculated value. So that is what you do here. You use the previous value of LPS, and if j is not greater than 0, in the sense like it is, if it is at the very beginning position, you make it as 0. So I plus plus. So basically this algorithm is going to do this function, find out at the set position. So you passed up until this particular position. So within this given already matched text, what is the common suffix and what is the common prefix, that is going to be found out by this algorithm. So after this, you will be obtaining a single dimensional array wherein we will be finding out at each position what is the suffix and common suffix and what is the common prefix that you are going to have at the set position. So that is pre-processing that you need, because here you have only one while loop with I is less than or equal to m. So in that case, the worst case complexity will be big O of m. And here this is the KMP algorithm. As I told earlier, the T is going to be the original text in which you are trying to find out the P, the pattern. So the length of the text is going to be stored as n, the length of the pattern is going to be stored as m. So you are going to compute the LPS, the common prefix and suffix table, list of prefixes and suffix, common prefix and suffix table, which will be found out by using the earlier discussed algorithm. So in this, what the KMP algorithm will do is, after computation of the LPS, initially we initialize I and j as 0. So this complexity, like while I is less than n, the n is the length of the text. So we, in each iteration, we first compare p of j with t of I. So initially I and j will be 0. So both characters will be the same. Obviously they will be, it will be equal. Then in that case, what you do here in this case is, when they are equal, if j equal to m minus 1, what do you mean by that is, whether in this step you are trying to find out whether you have reached the end of the pattern. So if it is that case, if you have reached the end of the pattern, then I will be returning I minus m plus 1. Otherwise I will just increment in the ith position and jth position. So that will happen in here. So else what should I do is, if it is not that case, if the character p of j is not equal to t of j, then I need to find out if j is greater than 0. If j is greater than 0, in the sense somewhere I have matched few of the characters already. Here it is not matching. Then if it is not matching, then what should I do is, I need to consider the j minus 1th value that I already computed and stored in the LPS, the prefix and suffix table. I will consider that. If else, in the sense like if j is not 0, then greater than 0, then otherwise I will just increment the position. So because I is going to be pointing to the text, so I will just increment the text position if it is going to fail, if it is not in between the pattern. So the output will be first occurrence of p in the t. It's not going, this algorithm is not going to return the multiple positions of the string. So this algorithm will drastically reduce the number of comparisons. If when you consider this case, say here I consider only a long sequence of zeros ending with 1. The red letter characters are going to be the substring. So when you compare the brute force technique to KMP algorithm, here you never you never compare the rest of the characters based on the substring that you are going to have. You just simply compare the only the essential comparisons based on the KMP steps that I explained earlier. So when you compare here, the worst case complexity with the best KMP algorithm, in the brute force techniques, to find out this substring within this original string, you need 210 number of comparisons, whereas when you use the KMP comparison, for the same pattern to be found out in the given string, you need just only the 42 comparisons. So where is the 210 and where is the 42? So you have enormous difference just with a string of length, say around it will be around 20 to 22 characters. But when you are going to have a string length of 22, say lakh characters, in that one, if you are trying to find out just a pattern of a string length of 10, then in that case the number of comparisons will be enormous. So enormously will be reducing the number of comparisons. Thereby your program efficiency will be very good. So the string patching algorithm, as I told earlier, the pre-processing algorithm, which will be having only one while loop, which is going to be compared with m. M is the number of characters in the pattern. So it will consume only the big O of m number of operations. So at each iteration, you are going to compare, you will be having the three different cases, whether it is equal, not equal. If it is not equal, find out whether it is in between or at the very first position. So three comparisons are going to be needed. Hence maximum, in the worst case, you will be having 2 into n number of iterations will be there. So we conclude with that the worst performance is going to be n plus m, because 2 is going to be the constant, and here for the p-processing you get something like m, which will be summed up. But if it is the brute force, then it will be n cross m or big O of nm. So that is the huge difference, that you n cross m will be very much n cross m will be very much high when compared to the n plus m, as the substring length and the text length are going to vary much. So we discuss we will try to execute some simple program, the KMP program. So here the program will be having the original text to be like this: A, B, A, B, D, A, etc. So the substring is going to be like this: A, B, A, B, C, A, B, B, A, B. So when you run this program, you try to get the output like this. So you found the pattern at the position 10. So if you here this particular position at the 10th position, A, B, if you start from here, A, B, C, A, B, A, B, you found it at this particular position, the 10th position. So this is what the output of this program. We'll try to just understand how exactly the LPS is going to work by debugging the program. So I'll just explain how it is going to be. So when you debug the program, then only will completely understand the program. Particularly here, you need to understand how you are going to exactly compute the prefix and suffix array. What exactly it is going to do is, it is going to find out the longest prefix and suffix that is going to be in common. So we will try to debug this particular program, and we'll take a breakpoint here. Sorry. So here I will put a breakpoint here in this case, and I will start debugging the program. So when you start debugging the program, when you put a breakpoint here, it will execute up until this particular position. So here, so by the time I come to the last instruction of this LPS compute LPS array, So it is going to pre-process and it is going to build up this particular LPS table. So what this LPS table is going to do is 0 0 1 2 0. So what exactly does that mean is, here you have A B C A B as a pattern. So at the, as I told, the very first position is 0 because the first character is going to be matched with, so the same A is going to be prefix and as well as suffix. So when you move to the bth position, even when you move to the bth position, this there is no common prefix and suffix, so then even LPS of 1 will be 0. When you move to the third position, A B A, so what does that mean is, you have a common prefix and suffix here. So the prefix is A and as well as the suffix is A, so that is why you have common prefix and suffix as a length of 1. So this algorithm will try to store it as 1. And when you move to the next position, B, so you have a prefix of AB and a suffix of AB which is going to be in common. That is why you say it as 2. So when you move to the next position as C, so C's presence is not there until the position of C here. So that is why, so when there is no match up until this position of C, you make it as a 0. So when you move to the next position, A, which is already found out here, which is already found as a prefix A here, so that is why you store it as 1. So when you have AB, which is going to be AB, which is going to be here from this position to this position, AB is a suffix and as well as it is going to be a prefix AB. The first two letters and these two letters are going to be in common, so that is why you store it as 2. So A, when you consider ABA, so when you consider ABA, which is going to be the prefix and as well as ABA is going to be the suffix, so that is why you store it as 3. So when you have AB as a suffix and as well as AB as prefix, so that is why you store at the 8th position as the 4. So what basically this LPS table is going to defend is, so it is going to be finding out at any particular position of position of time, if at any particular position of meanwhile you apply the KMP algorithm, if you fail to compare the respective positions of the pattern with text, then what should I do? So shall I compare it with the beginning? If it is the brute force, then it will start with the early from the very first character, but here in this case we will be using these values. So what these values will be, how these values will be useful is, so when you go back to the previous example here, so I considered an example here how exactly you are going to use the this particular LPS or the pre-processed table. So I consider this example here. So here in this case, up until this position of C and D, we found out that up until this position of C in the text and D in the pattern, there was a mismatch. So if there is a mismatch, find out in the previously parsed or previously compared all equivalent characters, find out if there is any common prefix to common suffix. So if it is that case, then I need not start again from the position of B. I will start with the position of AB here, because the common prefix I have, I will skip the characters, so I will start with the position of AB here. So that is what the intent of this program is. So that's how you reduce the computing time from big O of nm to big O of n plus m. So with that we conclude the KMP algorithm, which is most significant algorithm. So if you have any questions, please try to email me or WhatsApp me. We will continue in the next session with the second module of your syllabus. The second module I will start with. Thank you for watching. Hope you understood all the topics. If not understood, please try to reply back with your emails, with your interaction with either emails or WhatsApp.